The new R1 Works motors for 2018-2019, the new V21. These are the new versions of their all-conquering V16 motor, which has won many meetings indoors, outdoors, small tracks, big tracks, carpet, asphalt. 1S, 2S, done very well indeed. So we will expect that these new versions, the V21, are going to be some sort of improvement. They don't want to drop the ball. Also, they want to leap ahead of the competition. There have been a few new motors come out from Zombie, and especially, for instance, the Surpass motor, which is tested extremely well, and they want to keep ahead of the competition, and so they've waited till these come out, and then they brought their new version out. Before we have a look at them, I'm going to do the normal test, have a look what they're made of, how everything, test up the performance, set it up on this analyzer. But this time I'm also going to run it up on the minPro dyno, compare it to one of the best motors, say that Surpass, get all the results on acceleration, revs and everything on the graphs, and hopefully point out the differences better, or maybe worse, but I'm sure it'll be better than the competitors. So starting off with the motors themselves, I've got the a V16 here. Now this is the previous class winning one, so we can compare what it looks like, and I'm going to write down, by the way, all the results on these charts like normal, comparing it to all the motors that I've written down up to now. Here's the existing R1 motor, familiar with. That's a 13.5, and I've got a 17.5 here and a 13.5. Coming in the cardboard tubes, same little envelope, no additional information. In fact, on this one there's not even any writing on the outside. So here we go. Same kind of matte black, slightly more matte than the original. And immediately, obviously, we can see, although it's an evolution of the same motors, not a new design, you can see lots of new cutouts on the can for cooling. The tags have remained the same, but there's a lot of detailed differences. Initially, you can see the M bell has changed. The cutouts obviously in the front, there's more cutouts, so it's probably going to be a bit lighter. Looking at the collector, they've got the same big aluminium collector on the front. The length is to be the same. Shaft length. The shaft length they've reduced. I'd say they've got the shaft length down by at least 1 millimeter. The new short shaft length, same as the Surpass, is 13.8 millimeters, which is good. So we all know that the shafts are too long these days on cars. Shimming, good. Initially, strength of the magnet, nice and strong. The front, I noticed one thing straight away, the screws have got a much smaller head with a 1.5mm driver rather than a 2mm. I don't know if they're trying to save weight, but they look like they're steel rather than aluminium, which is used on some. R1 written around the front, which the original one didn't have, so it says R1, R1, R1. The bearing is less exposed now on the front. It's just the way that they've probably cut it out. The 3 screws are still 2mm head, which is excellent. Sensor board single down the bottom. There's one big change. Before we had the degrees marked around there. That's disappeared now. And you've got a little window. It says 30, so obviously when you move this around, the different degrees appear in that window. Yeah, the front comes off, still split round there. Much thinner amount of material on the front, so the weight's obviously going to be down. Can do some important tests from the outside. I can weigh it, obviously. Measure the all-important winding resistance. That's going to be key to if they've improved the winding. Can measure the size of the stator if necessary. And before I take it apart, we'll check the rotor. Another thing I did notice that the old one never had anything engraved. A lot of the motors come with engraving on the shaft, tell you what sort of rotor's in it. And this one does now as well. It's engraved, and you can see the flat goes all the way up to the front of the motor now. Some people had trouble where the flat only went part the way up when they put the pinion on. Did notice one thing, the 17.5 version has alloy screws on the timing end bell with a 1.5 driver, whereas the 13.5 has got steel with a 2mm driver. The winding resistance of the R1 17.5 turn version 21, 034, 035, that's nice and low. Let's just check another winding, 034, 035, so that's very low. Let's just check it against the best motor so far, which was the Surpass. Let's just double check the winding resistance of the Surpass V4S 17.5, 35036. So it looks like the jumped ahead of the Surpass, which had the crown for a very short time, and now the R1 has taken the lowest winding resistance from the Surpass. The only other thing I can do from the outside is measure the stack length. You can see at 94.49 there. On the 13.5 stack length, I'm getting only 19.39 and 19.53. For comparison, the old V16 13.5 R1 at 6 amps doing 4313. And the timing spread at 49 averages of 48, 46, 53. Adjusted the new R1 version 21 13.5 to a 6 amp reading, done a test. It's given a kV of 4172, which is a bit lower than the test on the previous motor. Timing average 49 with the 49 48 50, so nice tight sensor board, better than previous version. Near enough 50 degrees, so it's pretty close, which is very nice. The R1 17.5 V21 set up to 6 amps doing a 3403 kV. Timing 51 degrees and the spread 50, 51, 52, so again a good sensor board. And the marks on the end belts, 51 on the tester, on the end bell, yeah, just over 50. So the graduation timing there is very accurate. For comparison, tested the Surpass V4S 17.5 turn, set to 6 amps, kV 3526, and it's also a strong rotor as we know, so it's a good kV reading. Surpass timing's a bit higher, 54 with a spread of 55, 52, 54. Taken apart the 17.5 R1 V21. Now, as with the Zombie, the case has been a force fit, which is good because it transfers the heat nicely when it's pressed up against the case. So you can't really get it apart, but you can look at the constructions. There's the massive aluminium collector, like in the other one motor, and the stator. Now, one thing you can notice is it says 17.5, which has been printed on there. And as far as the stator goes, how do you know it's actually a 17.5? Well, on here, you can't see it, but on that shiny bit of the collector, it's got 17.5 turn engraved. So that's the 17.5. On the other bits that make this up, besides the winding, you can see the winding inside. They've used instead of the green epoxy, which a lot of the manufacturers have used to insulate the ends of the laminations, they've used a very, very thin piece of plastic or something just to stop the wire cutting through. They must have just stick that on before they wind it, which means there's no excess material. The winding looks typical though. Fairly neat, about as best you can do when you're doing all these things by hand. Those are the three connections on the back. A very short one to this top middle connector. A lot of people, when they're badly soldering, heat this up and keep on heating and heating and heating. They melt the solder off the connection to the wire there, which is always a problem on all motors. Also on the R1, they've still got very narrow gaps between the connections, and it's very easy to get solder in those gaps when you're not very good at soldering. Some kind of circuit board material that this is fixed to, but it rocks about a bit. There is another very thick piece of material that is jammed on the back to try and hold it in place and stop the solder running down, or whatever they decide that's used for. It does insulate this plate a bit, but that's that. Now, the actual sensor board, it looks like a fairly custom made one, not exactly the same as some of the others I've seen. Nice and small, single port, nice and rigid. R1 V21, and there seems to be a date on here, 2018/05/03, and that fits into this part, and the bearing on this one pushes in from this side, which is good, which means that you can shim this rotor up close without starting to push the bearing out of the housing, which you can on some motors where the bearings are fitted from this side, like I believe the Surpass. And there's also a little bit of insulation tape put in around there to prevent these connections on the back of the sensor board shorting out, which has been a problem on some motors where these connections have rubbed through the anodizing and caused a short. Everything has R1 written on it. This little ring has R1, which goes on there, clamps that. Those are you can see all the timing marks now that are written around there, and that appear through the window on the end valve. This part, little window, and this part's very lightweight indeed. Keep the weight down. The front, yeah, they kept the weight down. They completely machined it away about as much as they can before they run the risk of it deforming under shock loads if you crash your car. It's about as thin as you can get, I think. And the long screws, steel, not alloy, and they do have the tiny 1.5mm head. And these aluminium ones on the back are just, in my opinion, are terrible. You round them out in next to no time at all. The steel ones that are on the other motor are much better. Usual amount of shims and things. Now the rotor itself, I'm just going to measure the Gauss in a second. Again, very familiar, like the one I showed you from the Zombie in the previous video and the Surpass. Looks like it's made by the same people again. There's a step down here, black ring with the epoxy on the front. This one has R1 and then the code, which is 125704, engraved around the front. I'm just going to measure the Gauss on that one in a second. So those are the parts. Nothing that exciting. They've tried to keep the weight down. And the end bell, nice little design with the window and everything. The size of this rotor, I can measure that as well. Let's just see what the length is. We know that the longer rotors these days give the better performance, and magnetic length I would say was about 24.6. Diameter 1245, yeah, dead standard. 2 poles, north and south. 1470. 1462, so it's one of the slightly weaker ones. Some of the ones we've tested have been over 1500. So as I said before, all the motors, the differences you're going to notice are very small, unless you just need lots and lots of bottom end, and you'll get the one, the stronger one, but I doubt if you'll ever notice on the track, as long as they don't go too weak. The rotor from the 13.5, minus 1461 plus 1461. Well, perfectly matched. It couldn't get better than that, but still not fantastically strong. Magnetic length 24.5, not the longest we've seen. Shimming the rotor to the sensor board. Because of the design, it is possible to, if you leave the shims off, to hit the sensor board, which will break it. So if you do ever take these apart, make sure you put the shims back on. Just don't put it too close, and make sure it spins without any knocking at all. 13.510 is actually etched on each of those collector parts that jut out, so you can, it's quite clear it's a 13.5 turn. The insulation plate on the back seems to have been glued on, and this one doesn't rock like the 17.5 one did. Testing the motors on the minPro dyno. I'm going to do the 17.5 turn motor because I've got the Surpass 17.5 V4S, which I tuned to 6.0 amps with a Speedo hobby wing set to blinky, and a fully charged battery, keep fully charged, and I'm going to run it up and record the results on the screen here. I'm going to record the RPM reached and the current drawn, and I can do another test to work out the efficiency. Now my custom sequence for this, it'll do 15% throttle, and then the 50% throttle, then 100%, and then 100% brakes, which should show you the current draw and the RPM reached and the acceleration speed. So it'd be quite a useful graph for comparison purposes. So battery's fully charged. I can start a sequence here. I have to turn on the speedo into blinky mode. Got the throttle connected, so I'm going to start sequence test 1. and it's finished. And we can look at the graph here just quickly, just show you some of the things it's done. I had this is seconds along the bottom. The whole thing took 16 seconds. First 2 seconds I just had 15% throttle just to see if the motor can in fact turn with a little bit of throttle, what sort of RPM it does. Got to about 2000. Then I added 50% of throttle, which gives you a current spike. You can see the current on the left, and about 30 amps, and the acceleration time and the revs it reached about 12,000. Then we hit the 100% throttle, another spike in current up to 50 amps spike this time, and the acceleration time, and it was still accelerating up to that point there. We have to stop at some point, so it would just keep on going till it peaked out. Oh, here's somewhere too long. It's about 23,000 RPM. And then the brake time, well, the strength of the rotor, for instance, will give you the braking curve as well. The middle one, that's just the voltage. We don't really need that. So we've got the current pulses and the acceleration of the motor. So I can save that, a test description here. I'll just put what it is, and then I can fit up the R1, which is also tuned to 6.0 amps on the timing. For the R1 efficiency comparison, I have to run a slightly different graph. On the graph, the blue one's the efficiency of the R1, and the brown one is the surpass. You can see that they've both got flat curves, so you can gear all the way up to here is no problem. You normally push it over a bit, 19,000 RPM on both, but you can see that the efficiency on the surpass is only about 53%. On the R1 it's at least 57%, so a little more efficient on the R1, which means less heat generated. Maintain performance without overheating towards the end of the race. Small difference, but it is better. Going to run the sequence to check the acceleration and the RPM. I've overlaid the two graphs of the R1 17.5 turn and the surpass, and so you can just see any differences. I'm just going to amplify it for you, and the two lines here, this is the amps and this is the RPM. So just looking at which one is which, the blue one which the blue one is the surpass, the green one is the R1, but they both start off just part throttle about the same, then they take off here. There's a current surge about the same, but the R1, yeah, it's about the same. R1 slightly less current, and now the curve for the RPM, the steeper the curve, more vertical, the quicker the acceleration. You can see the R1, it's got a tiny little bump, tiny amount, not much in it, and then that's 50% throttle, then at 100% throttle here, hit this point. You can see the current surges, and then the current on the R1 drops away. That's why it's more efficient on the efficiency graph. And again, the R1, slightly quicker acceleration just here, not much in it. And top RPM reach, but they're still both accelerating here, with the R1 just slightly ahead by a few hundred RPM, not much in it. Then they hit the brakes, and the R1 fractionally better brakes because it brakes sooner, but it did start off sooner. The software where it switches it is slightly offset, so you can see it did start off fractionally in front of the other one. But both these brakes are excellent. I mean, these steep curves, I doubt if you'd notice any difference on the track between these two motors, either in acceleration or brakes. The only thing that is slightly different is the efficiency. If you were running it really hard without proper cooling, the R1's going to be fractionally cooler. But both motors are performing it very well, but the R1 is just edging it. I'm going to minPro dyno the V21 13.5 turn motor, and then I'm going to fit the optional rotor just to show you what difference that makes. I'll do the RPM and the efficiency curves. Testing the 13.5 turn, I've set it up at 6 amps offload, and this is with the rotor, the standard rotor it comes with. So I'm going to do an RPM run and then an efficiency run. So we'll start with the RPM run. So that's the curves there. I can compare it to other motors if I want, but I'm just going to do the comparison with the rotors. So at the moment we've got the max RPM up here near about 28,000 RPM. That was a 15% throttle, 50% throttle, and 100% brakes. And the current pulses when it hits the throttle changes. See, it's quite high. It's about 70 amps on that one. The efficiency graph for the R1 13.5 turn with the spec rotor. You're looking at the graph. Ignore this bit here. That's I just do a 50% before I hit the 100% there. So this is the part we want to look at, the maximum efficiency, and as you can see, it's about 57%. It's a bit more peaky than the 17.5, but you gear it again for maximum efficiency. If you run in constant high speed, you gear it there, but on long tracks where you want maximum speed, it still keep pulling up to about here, 22,000 RPM. You wouldn't really gear it to go any higher because it's just the power and the loss of energy just gets greater. I'm going to fit the other rotor and check out what happens. The optional rotor is noticeably weaker, as if you want to just feel the strength of it like that. KV set at 6.0 amps. It's now up to 4,705. And the time in 50 degrees, 49, 50, 51. In the window it's about 50, just over 50, so it's very accurate, this little timing window. Testing the efficiency with the optional rotor in the 13.5 turn. And on the screen you can see the efficiency is the brown one with the optional rotor, and the revs are along the bottom. You can see that the efficiency's moved to the right, but it's a bit lower, and not noticeably a lot lower, nearly up to 55%. This one was like 58. The efficiency has moved to the right, quite a lot, quite a flat top, so you'd gear much higher now, maybe up as high as here, 24,000 RPM, whereas the other one was you were gearing down here at 20. So not a huge lot of efficiency, but the acceleration time and the RPM reached will be more important, I think. The RPM test with the optional rotor in the 13.5 turn. Looking at the graph, got a couple of different things to look at. Now the blue one is the original test with the spec rotor, and the brown one here is the optional rotor. It starts off slightly early on the software, so the acceleration seems to be almost the same, and then as it keeps going, a bit more RPM. I expected more, but nearly 30,000 RPM, and the other one was just over 28,000, so not a huge amount. The braking is soft as you expect with a weaker rotor, so the steepness of the curve, the blue one's better brakes. I'm quite surprised that the differences were not that marked. Not sure whether it's worth the effort of putting that rotor in or not. Looking at the current, that's the spec rotor, and then the optional rotor. Not much difference in the current draw, slightly higher peak. I expected a bigger variation. The differences fitting that rotor doesn't seem to warrant the effort really. I'm sure you could gear it to get these sort of additional RPM just at the top. Conclusions of the tests on the new R1 V21 motors, the 17.5 and 13.5 turn. I've got all the results here, and I've also tested it on the minPro, and we've also tested an optional rotor, and these are the two motors. So initially, as I've said earlier, the motors themselves are improved, lighter in weight, better cooling, shorter shafts, lower resistance. Everything has been improved, and I'll show you the results in a second. The only thing I don't like about them, these alloy or titanium screws, very soft. I mean, I adjusted hundreds of motor end bells, and these screws rounded out for me straight away. So far so good, but what about the results? I've got the 13.5 and the 17.5, so let's look at the 13.5 first. I tested the 13.5 with, as it came, the spec rotor, and also with the optional rotor. The kV readings on the analyzer, 4172 kV, that's at 6 amps, and the timing, the new sensor boards that they're using are very good. Compared, I've got the old V16 version here. Sensor board used to be all over the place. Now they've got their own one, and they've really made a huge improvement on that. This was at 6 amps. With the standard rotor, 4172, which is about the same, slightly lower than some of these others. The new Surpass motor, 4175, I tested two, and that varied a lot. 4175, 4310. The new Zombie motor, 4239. The old R1 V16 had I tested two, 425 or 40. So this one is notably down on the kV, which let's see if that's going to be a negative or not. With the optional rotor, it's way up. Now, the all-important stator resistance, this is one of the most important parts of the motor, specs of the motor, 0.021 across the board. The Zombie was 0.021 and so was the Surpass. The old R1 was 0.022. So these stator resistances now about as low as we can get. I don't think they can wind it within the rules any better than that with the best wire, the shortest stack, everything. So very good resistance. The Gauss of the rotors, I think these rotors all come from the same place as used in the Zombie, the Surpass, the R1. They look exactly the same. The shaft length is now shorter on the Surpass, 13.8, and it's 13.8 on the R1. The old R1 was really long, 15, and the Zombie is still long. And the flat on the shafts goes right up on the Surpass and the R1 as well, right up, which means you can move the pinion in nicely. The Gauss strength does vary a lot. I said these rotors, I think, will come from the same place. They probably don't select them out. This one on the R1 was particularly well matched, the north and south poles, 1461. Anything above 1450 up to just over 1500 seems to be the optimum range. These days for a 2S touring car especially, and also high Gauss 1500 odd, is very good for 1S. Other good points of the new R1, lightweight, 143.8 grams. And you can see it's nearly the Surpass Red, it's like 10 grams lighter than that. That's a fantastic saving in weight. If you need a lightweight motor on that side of the car, it's not becoming so critical anymore. Some people find the motor's actually too light now. Any other points on the 13.5? Well, the optional rotor, very high kV, much weaker magnet. So I wouldn't recommend it for indoor or small tracks. You can probably gear it to get the extra high speed, but I wouldn't bother, but you might want to if you're allowed to under the rules. So that's the 13.5. The 17.5, I didn't put the optional rotor in this, but let's look at the results. It's quite a different sort of result. The weight, 143.1, very lightweight. Again, it's 10 grams lighter than, say, the Surpass, and it's a little bit lighter than the Zombie. The rotor strengths, again, 1470. Slightly down on the Zombie, was a nice high strength one. The Surpass, one of them I tested was the rotors vary. I mean, this was in the gold one, that was over 1500, and this one was only 1460 odd. So I think these rotors, it's a bit of whatever motor you get might be high or low, but they all perform extremely well. Again, this rotor is the short shaft one, 13.8 mil. The winding resistance, the fabulous winding resistance on the R1. First of all, the Surpass had it 0.036 for a very short time. Now the R1 has got it 0.035, and perhaps even as low 0.0345. It's just flickering a bit on one of them. So winding resistance, they've managed to edge it a little bit more. That's impressive. I'm sure it can't go any lower. They must be. This is about as low as anyone can get from now on. The RPM and kV. Well, on this one, the kV was 3403. Pretty impressive kV anyway. But lower than the others, lower than Zombie and lower than the Surpass. Tested two. One was higher than the other. Still 3526, 3688. But all impressive kVs anyway. Timing, nice tight timing board. as was the Zombie as well, and even the Surpass. All these three motors are very good indeed. Probably on the track you're not going to notice the difference between them. Price, if it makes any difference to you, Zombie R1 for instance £90 in this country. Surpass is much cheaper. You want to save a bit of money. Now I did do the graphs as well, and that's appeared earlier in the video, and all I can say just once again is that it's up to you. I didn't find a huge improvement in fit in the optional rotor on the minPro. Maybe on the track it noticed up a little more, a little less braking, better RPM, and the efficiency was down a bit. And we did look at the efficiency graphs for the R1, and it's very good efficiency, about 57, a few percent higher than the Surpass, which is good, probably due to the winding resistance being a little bit less. So that is the conclusion. The R1 motor, I think it's just edged out everyone else, taking the P1 position again, top, but there's hardly anything in it. I think if you ran the R1 Zombie, Surpass, and possibly other new ones when they come out, which I haven't tested, I very much doubt you'll be able to tell in a blindfold test. Not that you're going to drive your car with a blindfold, but you wouldn't know which motor was in your car if they were geared the same. But you got to say the R1 has edged it, just looking at the specifications.